Well, let's start by noticing that there is nothing more that we can do with this augmented matrix, and in fact it is in row echelon form. If you go back and check, any zero rows are below all the non-zero rows. We have our leading ones in the correct order, and if we have a leading one in a row, then everything in its column is zero. So this is in row echelon form. This tells us it's reduced, we can't do more. So let's start by writing out the system of equations which this reduced augmented matrix represents. So if you look at our first row, well, this says that x1 plus x3 is equal to 3. And our second row says that x2 minus x3 is equal to 2. And our third row just says 0 is equal to 0, which we know is always true. So we actually saw this previously, and a system that looks like this has infinitely many solutions. Why do I say this? Well, if you pick any value for x3, then you can find a corresponding value for x1 and x2 that makes the system true. So x3 is what we call a free variable. And we express that it's a free variable by saying x3 is equal to, let's call it sum a, where a can be anything in real numbers. And now we express x1 and x2 in terms of that a. So we've got x1 is equal to, I'm taking x3 or equivalently a over to the left, so I've got 3 minus a, I've got x2 is equal to 2 plus a, and then I've got x3, which is just equal to a. So this is my solution. A is an element of real numbers. We can actually write the solution set as follows. Our solution set is equal to the set of all column vectors that look like 3 minus a, 2 plus a, where a is an element of real numbers. If we want to go and look at our previous example and write the solution set, our solution set for this bunny would simply be, let's put it small over here, s is equal to, well, it's equal to a single column vector, which looks like that. So when we have a unique solution, our solution set is just a column vector, but when we have infinitely many solutions, our solution set is a set of vectors, an infinite set of vectors. Okay, we have one more thing to look at. We would be interested to know if we have no solution, what happens? So here we go. We have 3 equations and 4 unknowns, and we want to head for row echelon form. So the first thing we want to do is have a 1 in the top left, and I notice that I have a convenient 1 in the bottom left, so I'm going to swap row 1 and row 3. So my new row 1 is 1, 1, 4 minus 5, 2, nothing's happening to my middle row, and my first row now becomes my third row, so that's a 2, 1, 7, minus 7, 2. Okay, next up, we now have our leading 1 in our top row, so we need to turn everything else into zeros. So I'm going to add 3 times row 1 to row 2. Okay, so not changing my top row, not changing my bottom row, and now I've got minus 3 plus 3, which is 0, 4 plus 3, which is 7, minus 5 plus 12, which is 7, minus 6, minus 15, which is minus 21, and 3 plus 6, which is 9. Keep going. We now want to deal with this 2, so I'm just going to subtract 2 times row 1 from row 3. So we've got row 3 minus 2 times row 1. So we've got 2 minus 2, which is 0, 1 minus 2, which is minus 1, 7 minus 8, which is minus 1, minus 7 plus 10, which is 3, and 2 minus 4, which is minus 2. Well, I've sorted out my first column, so it's time to move on to my second column. And what I need is I need to have a 1 in the second row, second column, and zeros elsewhere. So let's sort that 1 out first. Well, I don't feel like doing more multiplication than I have to, so I'm actually going to swap row 2 and 3, which is going to give me a minus 1, and then I can just get rid of that minus very easily by multiplying through. So I'm going to say swap row 2 and row 3. Not changing row 1. Putting row 3 in place of row 2. Putting row 2 in place of row 3. And we're done. And now very quickly, I'm just going to multiply row 2 by minus 1. And we're getting to where we can actually start dealing with our second column zeros. So this 1 is my leading one in that row, so I need to turn this 7 into a 0 and then that 1 into a 0. Let's deal with the 7 first, so I'm just going to subtract 7 times row 2 from row 3. So it's going to be row 3 minus 7 times row 2, not changing first row, not changing second row, and I'm saying 0 times 0, which means 0 minus 0, which is 0, 7 minus 7, which is 0, 7 minus 7, also 0, minus 21 plus 21, which is 0, and 9 minus 14, which is minus 5. And it might be tempting to carry on at this point, but if you look at what equations this represents, you can see immediately that this system doesn't have a solution. So we could write this out. So we could go and fully reduce this, but if you're anything like me, the less you have to do of this kind of thing, the better. So the key thing over here is to notice that we have a row of zeros up to the line, and then we've got a minus 5. Now in our previous example, we had a row that was only zeros, and that ended up meaning that we have infinitely many solutions. The opposite thing happens over here. This row in our augmented matrix says 0 times x1 plus 0 times x2 plus 0 times x3 plus 0 times x4 needs to be equal to minus 5. And as we saw previously when working with systems of equations, you simply can't find x1, x2, x3, x4, which when they're all multiplied by 0, gives you -5. So this is immediately no solution. So when you're Gauss reducing, which is what we call this procedure, or you want to think of it as finding the reduced row echelon form, as soon as you see a row which has zeros to the left of the bar and then a non-zero entry, you know that you have no solution and you should stop and go on with your life. So we've worked through 3 possible examples of the different kinds of solutions that you have and how you can find them using Gauss reduction. Gauss reduction is just one of those things you have to practice. So I suggest that you sit yourself down, work through these examples, and also work through the examples in the textbook. So if you go to your textbook, you'll see that we have an index of archetypes. So these are different kinds of systems of linear equations and their solutions. So we've already seen archetype B and A. You can look at C. So you can use these, practice row reducing, and see that you get the right answers. There are also plenty of examples in our chapter on row reduced echelon form. Which you can work through down at the bottom. So we've got more examples that are worked here, and then in the exercises, plenty of examples with solutions that you can work through. So spend some time getting comfortable with this, possibly work with a friend if you can. It's easy to make mistakes, so double check. And you can always use a computer algebra thing like GeoGebra to check your answers.